let's try to solve this problem here. So you have a point charge Q1 which is held stationary at the origin, and you have a second charge which is named Q2 which is placed at point A, and the electric potential energy of the pair of charges is positive 5.4 times 10 to the power negative 8 joule. Now, when the second charge Q2 is moved to another point which is called point B, the electric force on the charge does negative 1.9 times 10 to the power negative 8 joule of work. So it's a situation which involves changing the position of the charges from one initial situation to a final situation. Okay, later we'll try to draw it out to visualize the situation clearly. So they ask what is the electric potential energy of the pair of charges when the second charge is at point B. Okay, so let's try to draw the situation here. We have charge Q1 which is held stationary at the origin. So we call this place to be the origin. Okay, then you have a second charge Q2 which is placed at point A. So randomly we take a point and we call it as point A. Okay, so now you place let's do write A over here. Let's write so this is point A. Okay, then you place the second charge Q2 over here. Okay, and they say that the electric potential energy of the pair of charges is positive 5.4 times 10 to the power negative 8 joule. So I usually represent electric potential as similar to like elastic potential energy. So what I'll do is I will draw a spring that connects between these two charges, because that's how I visualize electric potential energy. It's like a spring, and it's a spring between two charges. So in this case, this spring over here has potential energy, and the potential energy is U equals to positive 5.4 times 10 to the power of negative 8 joule. Okay, so now when the second charge Q2 is moved to point B, the electric force does this much amount of work. So what happened here is the electric force do work. Okay, so do work in causing what to happen? Causing Q2 to move from point A to point B. Okay, so we can say we still keep Q1 at the origin, so we don't change the position of Q1. But let's say today Q2 is being moved to another position. Let's call this position B. Okay, and it's being moved to this new position over here. Again, I don't write my position down here. Use the space down here to write the charge. So this is point B. Okay, initially point A is somewhere over here. Okay, so I move my charge over here. So now the electric potential energy between Q1 and Q2, what am I doing? The electric potential energy will be a spring that connects between Q1 and Q2 as usual, but this time this will be another electric potential energy. Okay, so let's fill in the numbers. When the second point charge is moved to point B, so Q2 is now at point B, the electric force on the charge does negative 1.9 times 10 to the power negative 8 joule of work. So it's the electric force that do the work. How much work? Negative 1.9 times 10 to the power negative 8 joule. So we can say work done by the electric force to bring a charge from point A to point B. Okay, this is how I usually write work done. Alright, work done, then I say is by what? Either it's work done by the electric force or work done by the external force. Okay, you have to look at the situation. In this case, it's the electric force do the work. So it's work done by electric force to bring, in this case, Q2 from point A to point B. So the journey is from point A to point B. And this value here will be equals to negative 1.9 times 10 to the power of negative 8 joule. Okay, so this is the value that is being given in the question over here. you read closely, it's the electric force that does the work, and it does the work on the charge Q2. So work done on Q2 to bring the charge from point A to point B. Okay, if it's work done by external force, then we'll say negative 1.9 times 10 to the power negative 8 joule of work is required to move the charge from point A to point B. If it says like work required or work needed, then those are like work done by external force. It's your hand or some third party to do the work. But now it says it's an electric force that do the work, so it's work done elect. Okay, elect represents electric. Okay, so the question says what is the electric potential energy of the pair of charges when the second charge is at point B. So now Q2 is now at point B, and they ask what is the electric potential energy right now. So this is what they are asking for. So let's call this situation as U when charge 2 is at point A. Let's call this UB to represent the electric potential energy when Q2 is at point B. Okay, so we know that how to relate between the electric potential energy and the work done will be this formula over here. Okay, you might see two different forms over here. One is called work done equals to negative delta U. Another form will be work done equals to delta U. Both of them are correct under very different situation. If you see the equation to be work done equals to negative delta U, it's work done by the electric force. Or you can say work done by the electric field, or you can say work done by some kind of charges. Okay, in that case, work done by electric field or work done by electric force is equals to negative change of electric potential energy. Okay, always remember change is always final potential energy minus the initial potential energy. Okay, so this is the situation if we have a negative here. If we have no negative over here, means that work done equals to positive delta U, then this is work done by external forces. Okay, or is the work done required, or is work done by some other things, some other third party. Okay, so in this case, like I said just now, if it's negative 1.9 times 10 to the power negative 8 joule of work is required to bring the charge Q2 from point A to point B, then you see the work is required, then it means by some other thing that do the work, then it's work done external. Then you have to use this equation over here. Okay, most of the time in matriculation syllabus, it's work done external, but under certain specific situation, like in this case, when they say it's the electric force that do work, then you have a negative here. Okay, so let's continue. We are going to use work done elect over here because that is the electric force doing the work. So let's further expand this equation by writing down it's from A to B. Okay, like I say, when I write work done, I will write it's work done by what, and it's from what position to what position. I will state these two things clearly first before I do any calculation. Why? Because it allows me to minimize my mistakes. Okay, so now I'll write my second line. What I do right now is I'll take negative, then the delta U, I'll expand it to become U final minus U initial. That's the meaning of change of U, right? So I take U final minus U initial. So the final position is B, the initial position is A. That means by my final will be B, my initial will be A. Okay, always remember it's taking the final minus initial. So final is B, so UB, initial is A, so UA, final minus initial. So this will be equals to work done by the electric force to bring point charge Q2 from A to B. Okay, now we are done with this line. Let's do our substitution. We know work done by electric force to bring Q2 from A to B is negative 1.9 times 10 to the power negative 8. So you can write it down, negative 1.9 times 10 to the power of negative 8. Then you also know that UB is what you want to find. UA is already given in the problem already. So what you need to do now, you can write negative UB plus UA. So UA is positive 5.4 times 10 to the power of negative 8. So now you are just left with moving around plus and minus. So you can use your calculator to calculate everything. and you should be able to get UB to be equals to 7.3 times 10 to the power of negative 8 joule. Okay, so this will be the electric potential energy between Q1 and Q2 when Q2 is at position B. Okay, when it's initially at position A, this is the electric potential energy between Q1 and Q2. Now once you move Q2 from position A to position B, the new electric potential energy between Q1 and Q2 is this value over here. So as you can see, it's an increment. Before that is 5.4 times 10 to the negative 8. Now it's 7.3 times 10 to the power of negative 8. So it's an increase of electric potential energy. That's why the work done by the electric force is negative, because increase in electric potential energy is a positive delta U. So if it's a positive delta U, it must come with negative work done by electric force. Delta U is positive, then the work done will be negative if we use this equation over here. So you see work done negative here. Okay, so that's how you solve this question over here.